Welcome to the Data Center Troubleshooting Methodology session. First of all, I really want to thank you for taking the time sitting here with us. I know it's after lunch, it's prime nap time, and there are great sessions out there as well. Oops, probably need a clicker. So pay attention to this slide. I'm pretty sure this is going to be the busiest title slide you will see this week. My name is Jane Gao. I'm the technical leader in Cisco services. I've been in Cisco for 14 years. I started out as a software developer. So in 2005, I joined the tech on the wireless team. Then a couple years later, I moved down to the LAN switching. And the last couple years, I've been focusing on the data center switching. So I've been covering a couple different technology in the past. And my co-speaker, Rahul, here, I will leave the introduction to Rahul himself, but he is one of the best engineers I know of in Cisco Tech. So before we get started, I want to tell you a little bit more about what we do in data center switching. Whenever we think of switching, it's like layer 2. We handle all the Nexus platforms in Cisco. So Nexus 2000, which is the fabric extender, all the way to Nexus 9000. And we pretty much handle everything that cannot be grouped into layer 3, a protocol or a feature and above. Those are handled by different technology teams. So things like packet drop on your network, performance issues, QoS configurations, network loops, anything that has no clear explanation that's happening, like switch reboots every night at 12 a.m., that's us. So you get the idea. So for US theater, at least, each of the data center switching engineer handles about 1,000 cases a year. So anybody in this room dealt with what's the number did I say? Yeah. So any of you have handled 1,000 issues in the past year? Raise your hand. There's one. Okay. Yes, we actually have opening tech. So it's a big number. It's a lot of problems to solve. And in reality, 75 to 80% of the issues can actually be solved by just asking the right questions. Asking the right questions, apply the right tools at the right time and the right location. And you can solve probably majority of the issues yourself as well. And we also we work and talk to a lot of customers. Some of the customers are really smart. I mean, all the customers are smart. But many customers just, they don't take the most optimum approach when it comes down to troubleshooting. So they will take the long route or they will take a different direction than what tech would do. So today I want to share with you a tech secret ingredients, a methodology that we use that's simple, it's consistent, and it's effective. And hopefully that will help you to troubleshoot and cover the 75 to 80% of the issues that you see, or it saves hours of troubleshooting time when you do need to interact with the tech on complex issues. So we're good there. The agenda today, so I will just spend a couple minutes covering the Cisco Unified Data Center Solution. Our focus is going to be the troubleshooting basics, in which I will explain what's the methodology as well as some of the tools that we commonly use. Rahul is going to cover the case studies. So he will show how we can apply what we learned, the methodology, the tools, into a real-life case study and see how it can be troubleshot the most effective way. So last year, I did the session the first time. One of the feedback I got was, we need more case studies. It's too simple. So I had 2 case studies last year. This year we have 10. So that's there. And now, yeah, maybe you need to let us know, okay? So then we'll go to the do's and don'ts. Basically, those are the tech recommendations on how to best troubleshoot an issue on your network. If you do need to, or if you need to interact with the tag. Hopefully that will save you a lot of time. Data center solution. So Cisco Unified Data Center Solution has 3 elements. The unified fabric, which is basically the key element that will interconnect the other 2 elements. It's a highly scalable, secure network fabric. It basically achieves the requirement through 3 components: the scalability, the convergence, and the intelligence. So scalability, we have various technology that can be deployed depending on the need of your network. So OTV, fabric path, and the VXLAN. And convergence, basically we consolidate the storage network and the general data network. And intelligence is basically what makes everything possible. So all the Nexus platforms, Nexus 2000 all the way through Nexus 9000, as well as MDS 9000, they all built on top of the same operating system, the NXOS, which is a modular software built on top of Linux. So that's what makes everything possible. And this is going to be where our focus is for the troubleshooting case studies, because that's where the Nexus data center switching team focusing on. The unified computing basically combines the high-performance servers, high-speed network, storage access, virtualization, all in one single integrated computing platform. It simplifies the management because it's a single point of management on the unified interconnect, fabric interconnect. And it abstracts the personality of the server into a configurable element. Now configuring 1 server versus 1,000 servers, it's pretty much identical. Unified management is our orchestration and automation management, resource management. So that consolidates and delivers the fabric as a service. Now, when there's something down in the data center, bad things happen, right? It affects the employees, affects the business, affects your customers, damage reputation, and lose partner trust, confidence. So our goal today for this session, that's the reason we're standing here, is to be able to help you how to quickly narrow down where the problem is and how to quickly get you either a workaround or a solution in a timely manner. Any questions so far? So, we do have the question manager. So if you do have a question, you have the option to, of course, ask us right away. Or you can type in the questions, and we have a question manager in San Jose site. And we will also get back to you on the question, maybe not during the session, but for sure during this week, whenever we get time. So now that's the fun part, troubleshooting basics. How we troubleshoot? We troubleshoot based on our knowledge. That's one of the most common troubleshooting ways. So we see a problem. We probably know a lot of the time what the problem might be, what's the root cause, what's the solution. So in this case, I just use a math problem as an example. It's 7 times 9. Who knows the answer? 63. Okay, so that's the knowledge. You don't have to add like my daughter needs to add 9 times. The other way is strategy-based. So in this case, we still apply our knowledge, but the problem is a little bit more complex. So you cannot just see the answer right away. 24 times 41, without looking at the slides, if you download it, tell me the answer. 984. So how do we get to that? You multiply the unit with the tenth. 2 times 4, you get 8. Then you multiply the 4 with the 1, and you get 4. You put on the right side. Okay, now you oops. That was a little too. Now you multiply between the unit and the tenth, add them together. So 4 by 4, 16 plus 2 by 1, you get 2. You put the 18 there, starting from the 10th to the left, right? Then you just add the top numbers with the bottom number. That's how you get 299.84. I do encourage you to try it if you don't believe this is the right method. So now the skill pyramid. So when do we need to use strategy-based troubleshooting? When do we need knowledge-based troubleshooting? For tech, because we deal with so many issues, majority of the problems we probably already had experience in the past. We've seen it with some other customers. So majority of the problem will be relatively low complexity, in which case we can just solve them with our existing knowledge. Once in a while, we do see high complexity problems or unknown, something that we've never seen, a new feature that we have not heard of or trained upon, in which case we will have to apply the strategy-based troubleshooting methodology. So now you might be asking, according to the pyramid, there's a very small percentage of the issues that you need a strategy. So why bother spending the time to learn this? Unless you solve 1,000 cases a year, you probably have this type of pyramid. When the issue comes in, it's not seen before, it's unknown, and it might be some new technology, new feature, new functionality that you haven't had a chance to deal with before. And that is when the strategy would come in handy. Now, the answer to the tech secret ingredients. Understand the problem. I bet most of you are like, what's the big deal with understand the problem? It's like common sense. It's actually not. That's one thing I was talking to Rahul. I'm trying to see how we can explain this the best way. The things that look common sense, understand the problem. If I say customer calls in, network is down, is that a problem? No, it's a symptom. A lot of times we get a symptom, we don't get a problem. So it's very tricky and oftentimes challenging to go from the symptom to the actual problem. So how do we do that? We ask questions. We ask open-ended questions. And we ask them over and over until to the point we actually understand what the problem really is. And once we have, okay, I'm not good with this clicker thing. Once we have a specific problem to troubleshoot, the next step is troubleshoot, right? So we break down the issue from technology perspective. Is it a routing problem, or is it switching? Is it on specific VLANs? Is it across all different networks? Or depending on the feature, what kind of feature is being impacted, or the host, are there multiple hosts being affected, or just the server? Applied knowledge, which can be either general knowledge, how ARP works, right? What's the difference between unicast and multicast? When the traffic is being software switched versus hardware switched, if you have dealt with the switching platform from Cisco before. So these are type of knowledge, and the drawing is actually not that accurate. It does take multiple iterations. It's not just one single thing. So you have to apply knowledge, break down the issue, apply knowledge, break down issue, and during that time, still try to understand more of the problem. It's not just one-time deal. Just keep this iteration until you get to the point where it's possible to identify a cause. So if we understand there are only certain servers having one particular issue, all the other servers on the same VLAN works fine, we might want to start with the servers, right? That's kind of like smoking gun where we can focus on. And the last one would be test the possible probable causes. Once we are able to narrow down what the issue might be, we can apply different workaround or possible fix and see if that indeed fixed the issue and confirm the root cause. So our focus today, again, will be on the understanding problem and how to troubleshoot. a problem well stated is a problem half solved, which is very true from our tech experience. A lot of time we spend more than half of the time trying to understand the problem, trying to collect all the data that's relevant to the issue that's being reported, the symptom, then actually troubleshoot it. That just blinded me. So step 1, understanding the problem. The 5 W's. What, why, when, where, who, right? Why the 5 W's? Those are all open-ended questions. So keep asking the open-ended questions. Really understand what is going on with the issue or with the symptom that's being reported. And the H, how did it happen? What has changed? Which is very crucial as part of the understanding problem. What is not the problem? This is one thing that people often miss, actually. It's as important as what is the problem. So for example, you have a performance issue on your network and you ping the switch. It's slow. The ping has latency. Is that really the problem? No, it's not. If the switch is doing its job as it should, all the data traffic should be hardware switched. Ping the switch itself causes traffic to get software switched. So it's done in the CPU. It's completely separate forwarding path. So that is not your problem, and that is probably not the right way to troubleshoot. And it has 2 parts, situation assessment and problem definition. The reason we want to do the situation assessment is sometimes the problem comes in, the symptom comes in, but you have actually multiple issues in one. It seems to be showing up as the same thing. Once we understand more data, we ask more questions, we'll find out there are maybe 2 or 3 problems inside. So where do we start with, right? So you have the situation assessment. We start with the most critical issue, or we start with something that's really important, but it seems to be more straightforward to troubleshoot. And hopefully once that one is solved, it will solve the other issues as well, or give us more data point to work on. So now let's look at an example, a performance issue. This is the initial description. So all these problems we have listed in these slides actually are real customer issues. On my slide deck, I actually have the case number listed as well, but I don't think that's going to show up in the PDF, which is good for me. So initial problem is network slowness, packet drops, came in as P1 because it happened in the data center. So now we ask the question, when did it start? Right, that's if there's any changes. What has changed? Where exactly is the problem happening? Is it on a different various data center site, or is it just one local site, or is it with a pair of core switches? Is it with multiple VLANs or one single VLAN? What are the hosts being affected? Just all the open questions who are affected. From that, we get to the first pass. So in hardware programming on the Nexus platforms, we use this term pass. So if a packet needs to be encapsulated multiple times within the forwarding ASIC, we call it pass. So this, I'm just borrowing that term. Basically, we have to iterate the same question, same methodology over and over until we get to a specific issue. So now you probably already read. I'm not going to read the whole sentence. So you can see it appears to be something very vague, network slowness. Now we understand a little bit better, right? The applications are being affected, users are complaining, there are timeouts. The world is coming down. It's scary. So we apply the same questions. How about basic connectivity? Who is really affected? Give me 2 IP addresses, for example. Where are they connected? Very specific questions at this point. Basic connectivity. Best way to check the basic connectivity is ping, right? It's straightforward. Everybody knows how to use it. So now we have a test laptop and we have an application server. So ping between the 2, we're seeing latency. That's a big big step forward. Now we don't have to troubleshoot mission-critical applications, understand how the applications work. We can just focus on the ping. Once we solve the issue with the ping, we might be able to solve the issue with the application as well. And we don't have any drops on the 7Ks. The Nexus platforms are really good, logging the error counters, the drops. So we don't have that, but it doesn't mean that 7K is not the issue. So let's see how we can actually get a little bit more information on it. So who else? Who else is seeing the problem? What is not a problem? Where else are we seeing the problem? Now we have a test laptop, right? But from the test laptop to the application server, it still has a couple hop in between. What we want to do is really narrow it down to as simple as possible so we can focus on the troubleshooting. So now let's try to move the test laptop to the same access switch as the application server. Okay. So now pings go from the test laptop to the application server on the same access switch, bypassing the core. We're still seeing the latency. What does this tell us? It's probably not something with the core, and we probably don't really need to focus on a multi-hop network forwarding path or any of the mission-critical application. At this point, we have a very clear and specific problem description that we can focus on. All right, any questions so far? Yes? Yes, if you have a router, it may or may not work. It depends on the platform. Remember, I was mentioning when you have a hardware forwarding data path versus software switching path, it's not always, well, it's usually not the best way to troubleshoot it. Because if you're pinging from switch to switch, the traffic gets, what we call COP, control plane policing. So it will get policed. And the forwarding path, so let me say this. If you have switch A to B to C, and you're suspecting the switch B in the middle is the one, from A to C, the traffic going through the B, that is done in the data plane, which is in the hardware forwarding. So if you're trying to ping the B itself, it goes to the software. So that is not the right way. But if you can find any two devices, as long as you know the traffic is not going to be policed in any way, you can do it. So if you have router on the two sides, you can do it. That will be fine, as long as you make sure it's taking the same path. Sure. So problem 2, OTV configure assistance. How many of you think it's a configuration problem? Okay, it's not. So once we get on the call, speak to the customer, the actual issue is with the connectivity. So SVI brought up as IB. It's pretty vague, right? So a lot of questions, what is IB? What kind of connectivity issue? So we asked the same type of questions. When did it start happening? Was it working before? And what is not the problem? Like, where does it work? Do you have a reference site? Because it's specifically called out site B, so they probably have site A, probably have site C. So the first pass, we have vCenter at VLAN 224 and the hosts on VLAN 130. They have been present on site A and everything works fine. So now a customer is expanding their data center and they started with the site B. They added these two VLANs into OTV. They turned on the VLANs on site B, turned on SVI. As soon as they turned up the SVI, they're having this issue. They are not able to add a host into the vCenter. Again, how about basic connectivity? What do we do with basic connectivity? We do a ping. So what is the problem? Where does it happen? And what is not the problem? Where does it work, basically? Once in a while. Okay. So does ping work? Ping is going through fine. Now what? Application is still failing. What are the differences? What are the differences between a ping and the application from packet level? Okay, you're not allowed to talk anymore. So packet size, packet types, right? Those are the two top things. There might be some other differences, but that's where we can start. It's very simple, very basic. So ping with the packet size, 1430 is going through, but not with the 1430 and 31 and above. So at this point, what we know is it's just MTU issue. It's not vCenter, VM, like all the data center interconnect, OTV, everything, right? MAC flapping and packet drop. So this issue actually came in as, again, priority 1 because it was causing some pretty catastrophic issue. They have mission critical application server as well. Same way, oops. When did the problem start? What has changed? Where do you see the issue? Right? So connectivity issue is reported across Fabric Path network. This actually went to our sister team who handles, they're very proficient with the MAC flapping, packet drop type of issues. But as soon as they see Fabric Path network, they get a little panic. They're like, that's something that I don't know. We can't handle it, escalate. So that escalated to my team. Then it's been working for over a year and there's no known change. But one thing they do see is there are MAC flappings. It's going to a pair of remote Fabric Path N5Ks. So it seems to be really complex. We don't know how big their Fabric Path deployment is. So now what do we do? MAC flapping is pretty simple. Everybody knows what that is, right? So basically you learn a MAC address from one port and you learn MAC address from 2 different ports and it flaps between the 2. So first thing, where does it flap exactly? So we see the flapping is happening between the 2 links going to the remote Fabric Path switches. And then what, right? The first thing we want to find out is what do we see on these 2 remote switches? Is it really a problem with Fabric Path? So we tracked it down, and it's actually flapping on the switches themselves, going down to a host that's connected on the VPC, on the fax over a VPC link, which is basically nothing but a port channel. The Fabric Path is not, it's the CE port for the Fabric Path. So it has nothing to do with the Fabric Path. It's basically narrowed down to a port channel instead of Fabric Path. Okay?
How do you fix that?
Oh, that was a bug. So, good question. So yeah, so basically the VPC is supposed to be treating the ports as member ports within the port channel, but from that particular bug, it was treated as individual ports within the port channel. So step 2, troubleshoot. I mentioned some of these earlier already. So break down the problem. The whole point to break it down is to simplify. A lot of issues start with across the network, everywhere, everything's done. You know, we want to simplify it. We want to extract what really is relevant to the symptom, to the problem that's being reported. So we want to simplify according to topology. So network diagram, that's always a big help, right? You have the diagram, it's visual. And technology, is it routing? Is it security? Is it voice? Is it actually forwarding? Just basically traffic forwarding. A lot of time we see issues like calls are not registering. Is it a problem with the call? Probably not, depending on which phase the call is trying to register. Maybe the phone is not connecting to the call manager. That will be still packet forwarding, connectivity issue. Apply knowledge and experience. So yeah, if someone doesn't have a whole lot knowledge, that's unfortunate. Just kidding. So you still have the methodology. That's where it comes in. You still can ask all the questions. Really understand what the problem is. That will save tons of the time. Even if you need to escalate, you need to pull in your colleague or call tech. Always helps. What are the changes? What has changed? If everything has been working and all of a sudden it went down, it doesn't mean that if there's no known change, there's no change. Because there has to be change to cause the difference. It might be something in the hardware, it might be something in the software, it could be race condition, could be corner condition. There's change, that's the change that we're trying to find out, which is going to be the root cause of the issue. Identify the possible causes. We can quickly rule out, if we can quickly rule out something, that's great. But if you're not 100% sure, keep it on the table, right? Don't just take it off, because sometimes the root cause that doesn't look to be very apparent turned out to be the one. So it's something that we learned the hard way. I don't want you guys to go through the same learning curve. Unless you're 100% sure, even that, still leave it on the table. Test the most probable causes. Right? If you can explain all the symptoms, satisfy the condition, and try different tests. If you're suspecting the host has maybe some misconfiguration, change the configuration. If possible, see if that fixes the problem. What do we really need? Just some logic, right? Some logic, some very simple tools, which I'm going to show you in the following slides. Packet drop. So they have two filer heads. You guys can read these. So the customer actually did a really good job identifying a specific problem for us. So we can skip understanding problem issue. So if you're reading slow, too bad. Topology. That's when the topology comes in handy, right? You have all the words. All we need to know is a topology. So you have filer 1, filer 2. They're connected VPC into a pair of 5Ks. We have 21 ping requests going from filer 1 to 2, and only 17 come back. And we know that's the problem they're trying to troubleshoot, and that's where we come in to help. Okay, this is doing that again. So now we start narrowing it down. It's pretty simple topology, but there are still multiple paths, forwarding paths. There are 4 forwarding paths. Everybody knows which 4 I'm talking about. You go this way, you go that way, and you can go both ways. So that's 4 different forwarding paths. We want to narrow down in the failure scenario which forwarding path is actually broken, it's causing the drop. And also which direction, right? As well as which link. If we can narrow down to a single link or single device, that's golden. That's what we are trying to get. And the tools I'm going to use here is called the PACO. Sniffer customer already did on the filers, where they were actually see the packet, the ping going out 21 and coming back 17. So PACO is port ACL. Anybody has used that before? Of course, I see some hands. So this is actually really powerful tool. I didn't really get to know until probably the third year after I was working on the switching team. It's very simple to configure. I have some example later on. It's very simple to configure. It's not service disruptive. I know you guys are very cautious with that. And it gives you a hardware counter of how many packets are coming in. So basically, you set up the echo for specific traffic flow you want to monitor, and you see the counter incrementing. So let's say if we send 21 packets, do we see 21 counter, like 21 as value showing up by the counter? In this case, So PECO can only be applied to the ingress direction. So in this case, we know filer is sending 21. I configure PECO ingress on Nexus 5K2. I see 21. That's not where it gets dropped. I can't do anything there, but on the filer 2, customer was able to do a sniffer capture, and they saw 21. So we're good on that link. Coming back on filer 2, they were seeing 21 being sent by filer 2. But on 5K2, I don't get 21, I get 17. So at this point, I've narrowed down to a particular path, a particular direction, and a single link. So when we have this type of scenario, another thing that's we can use our knowledge and experience is with the port channel. You probably all noticed there are 4 links, right? Do we need 4 links? Probably not. It's designed for redundancy. So you can check how much bandwidth we really need. A quick test will be bring down 1 link at a time. In the port channel, I'm not talking about between the cores, but bring down 1 link within 1 member port within the port channel, assuming you do have sufficient bandwidth to handle all the traffic going through the link. And usually, if it's hardware-related issues, we should be able to narrow it down or confirm. Once that link is down, everything works fine. That's probably the link we wanna deal with. So in this case, we did the same thing. We brought 1 link at a time, and the problem is still there. So it actually turned out to be, on the filer, all these 4 links are sitting on the same NIC, and that particular NIC is not seeded well. So eventually, we decided to reseed the NIC, and problem went away. Was customer happy? This problem was solved in 1 single call. They were not, because they started out at the filer. They had a case going on for 2 months. And on the filer side, the vendor was doing all the span sessions. They were swapping out different motherboards, NIC card. For some reason, they just didn't get to this point. So that's a lot of waste of time. But you can see with our methodology, the way how we troubleshoot in TAG, it doesn't really need to take that much time. So OTV config assistant, I'm just going to continue from the previous understanding example. So now we narrow down to MTU issue. Let's take a look at the topology. Whoa. Okay, so we have 3 data centers. They're interconnected with each other through multiple service providers. We know there's MTU going on. How do we narrow it down? Right? It could take days, hours, days, months even. So what is the traffic path? That would be the first question. To narrow down the traffic path, we know it's data center 1 and 2, so let's focus on that path. Is it an issue with the service provider? I think most of you probably have the same questions. Because once it gets to provider, you have to open case with them. It's just a lot of additional overhead. So if we can rule them out or narrow it down as service provider, that helps a lot with the troubleshooting. So ping from DC1 edge to DC2 edge with a larger packet, and DF bits set to DF bit set basically do not fragment. That's what the bit does. And see if the ping is successful. If it is, you know it's not with service provider. It's with your own network. Now we can narrow it down further. Ping from the joint interface to the edge and see where the MPU is not set correctly. And if MPU is all set correctly and ping is still not going through, now what? This is actually one case I handled. We took quite some time to go through the interfaces on the path, trying to find out where the MTU is not set correctly. It turned out, I think it's going to do that again. Is it right interface? So I thought I knew 100% that was the right traffic path. Turned out it wasn't. So they didn't even use a join interface. They used another layer 3 interface on the switch. And the ping was going through the layer 3 interface where MTU is not set. And we do have some bugs I wouldn't like to admit. But yeah, if you see everything's fine, everything's set correctly, it's probably time to call TAC. Okay? So next is 5K forwarding issue. The customer opened a case with this problem description. There's always 6% packet loss. It's really strange. So when we have this type of issue, the first thing we think is, could it be rate limiting? Because if it's always 6%, might be something that's rate limiting it. But again, the very first question we would ask is, can you show me? Can we actually see it? To verify whatever that's being reported is actually what's happening. So I didn't make you guys to read the whole article, but this is the topology. So they have back-to-back VPC. It's in terms of troubleshooting, in terms of deployments, this is great. Great redundancy, but in terms of troubleshooting, it could be a nightmare because there are so many different paths that the packet can be taking. So again, in this case, we did actually, customer did the packet capture on the host and on the 5K. They see the host sending all the traffic, but 5K is not returning. That's why the case was opened on the 5K. So the customer is actually really smart guy. So he opened the case on the 5K. Not necessarily he believes that's the problem, but that's where we can start, which is a very good thing to do. Finding a starting point. Okay, so with this, we use the same type of tools, PACO, port echo, sniffer. And now since we have the switches in the picture, we can also use the CLI. There are tons of CLIs that provide very useful information to help us to troubleshoot. In this case, port channel load balance forwarding path. So in order to find out which path, so once the traffic gets to the 5K, it could take either 7K1, it could take either 7K2. So instead of trying to set up sniffer capture on your core, you could run this command and find out which link it's taking. Then you can set up the PACO on the two 7Ks just to confirm. So one side, you should see the counter incrementing when you're sending the traffic. The other side, it should stay at 0. Sure. It's only for ingress. I'm not applying for outbound, I'm applying for the inbound. So we know the traffic is coming from the host to 5K. So now 5K needs to send over to the 7K. So this is where I apply it. So on the 7K side, ingress. Okay. So the question is PACO only ingress? So in this case, we're going to apply the PACO. We found out this counter is incrementing. And we use the port channel load balance forwarding path. We find out it's going to the 7K4. And then we apply the same PACO on 7K3, and we don't see all the traffic. I put a cross mark here, but does it mean this is where the packet gets dropped? No, it doesn't mean that. Okay, so just to clarify that, because we know the packet does come in on the 7K4, but we don't know for sure if it actually gets egressed here. And we don't know if this link is where it's faulty or the module. So there are a lot of, but at least we can narrow it down to a specific device or a specific link. So going from the overall double-sided VPC setup, now we're only troubleshooting here, which is exactly what we want, applying the methodology. So this particular issue turned out to be a module failure on the 7K3. So once the module gets swapped, everything was working fine. Yes?
Yeah, I think that in reality, like, this is really tough situation for troubleshooting, right? Mm-hmm. My question to you is like, how you know which path you take? Because there are so many different redundancy paths. So
right.
How you know which path you have to apply that path?
Right, so the question is, in this scenario, it's difficult to troubleshoot because of the redundant links. How do we determine which path it's taking? This particular example, actually, I just use a port channel load balance. So if you issue the command on the 5K, for example, with the source destination IP and the VLAN, depending on, I don't remember on top of my head, depending on the load balance algorithm, you run the command, just issue question mark, it's going to prompt you what field you need. It will tell you which interface is the egress interface.
You have to be lucky enough to just catch it, right? Because it could be like, maybe today you have that issue, and later you don't, and another day you can do that.
Yes, for intermittent problem.
This like switch or hardware or channel field. So it has to be some luck.
Well, with the port channel load balance algorithm, usually if you have the same source destination, it should always take the same path. So if you have a way, that's again, it's really important to identify a pair of IP addresses or specific hosts that you can recreate the issue. So yeah, exactly, you're exactly right. In this particular scenario, we actually had to wait because it's 6% of the packet job. It doesn't happen all the time. So every time we do a packet, we have to wait for about 10 minutes until we get enough data. So yeah, sorry, yes. No, it was actually, so the question is, I was mentioning earlier, the result was due to a module failure. The question is, was it significant enough to show up in the log? No, unfortunately, because if it had shown up, it would have taken me 1 minute. In this case, it took me like good 1-2 hours. So sometimes the hardware failure actually doesn't show up. It doesn't show up anywhere, and you don't even get error counters because it's failed in the hardware. In order to be able to pull the error counters, the software still needs to have a way to communicate with the hardware, which doesn't always happen. Okay. So verify the root cause, test against conditions, test against cause. I think you guys are pretty good with that. Just make sure everything does work as it should. It's not uncommon to see people say, okay, we fixed the problem, and a day or two later, it just come back again. So I'm going to recap. I hope this is not that much of common sense now. Understanding the problem. Okay, so we go from a network slowness to something more specific. For example, host A to host B. When they do a file transfer, they are seeing slowness. So if we can get a more specific description, like it used to take 2 seconds to transfer a file of 1 gig, and now it takes 20 seconds. Things like that will be very helpful. So then we can, there you go. We're done with the slide. So yeah, break down the issues, network topology, layer 2 versus layer 3, what are the hosts being affected, which VLAN, right? Apply knowledge. Forwarding path of traffic is always really important. Layer 2 versus layer 3. I called out ARP just because the importance of ARP in our networking. That's the first packet a host is sending when they need to talk to anybody. Confirming the root cause. So let's say if you have a scenario where only 2 hosts are having issue, or only hosts on specific switches having issue, you know what to look for. Test probable causes. Right. So the toolkit, I covered some of the tools already. So this is some more details. Sniffer capture, there are different types of sniffer captures. We have span. Everybody knows what it is. Cool. So yeah, so basically you can configure a switch, a span session on the switch. Then you can monitor whatever the source port is and send out traffic to the destination port where you connect an external device running Wireshark. Some customers have different applications to do that span as well. Yes. Yes, it is. So the question is, it's kind of difficult for Nexus because of the amount of traffic going through. So usually this is my last resort when it comes to troubleshoot network forwarding path. It's last resort because sometimes we do still need that. But PACO would help in a lot of scenarios. And there are different type of tools. If the traffic is going to the CPU, we can use something called Ether Analyzer. So this is nothing but a Wireshark built in on the Nexus platforms, which captures traffic going in and out of the CPU. I'm sorry? Correct. So all these tools, basically, you have to do it when the problem is actually happening. So if the customer sends me a sniffer capture saying, okay, we have a problem, the first question I would ask is, when did you capture it, and where did you capture it? Did you capture the problem situation? Because I love reading sniffer captures. I was a developer, so it takes me minutes to go through a couple hundred meg sniffer, but only if it actually has problem captured. So yeah, that is a very good point. We do need to make sure to capture the problem when it's actually happening. TCP dump usually on the Linux host, so some operating system, you would have that Wireshark, it's everywhere. So this is, the good thing with the sniffer capture is it's commonly available, and a lot of appliances, you can do that. Like the example I gave earlier on the filers, they can actually do sniffer on the filers. For Cisco firewall, you can do that. All the Nexus platforms, you can do that. And it's actually really useful for intermittent packet drops. We have some other tools available. We'll come to that, but sniffer is really useful when it comes to intermittent issues. The cons, it could be time consuming, and sometimes, as you mentioned, it may not be the best way if you have like gigs of traffic per second. So it's gonna fill up your buffer in no time. Yeah, for Ether Analyzer, it's a little different because it only captures traffic in and out of the CPU. The Wireshark here, I was actually referring the general term Wireshark. And maybe I can talk to you offline. Thank you. So this is PACO. That's just a quick example. This is what enables PACO to do the counter in the hardware. And usually, this is a very typical configuration. So, for example, I want to see this particular traffic flow. Do I see how many packets do I see going from this source to the destination? And this is very important. If you don't want to cause network down, make sure you have that one here. Okay. Again, it's very commonly available on the switching platforms. It's very easy to use. It's really quick. It's not service disruptive. And it's also very useful for intermittent packet drops or performance issues. The cons, one thing is it's ingress only, okay? And it does require configuration change. So for some of you, which is very strict to apply any configuration change, this might be not available at times. Add a log to the end? Yeah, we actually don't recommend it because once you add a log, it causes traffic to be pumped to CPU. So if there is tons of traffic, it's going to cause some high CPU or packet drop. So yeah, the PACO would be the better way to do. Ether Analyzer, Rahul is going to show you some examples during his case reviews. But basically, it's a built-in sniffer for CPU-bound traffic. One thing, there are different options you guys can certainly check. There are also configuration guides on CCL. But the things that I do want to point out is it does not capture the data plane traffic forwarded in the hardware. So if the packets are going through the switch, which should have been forwarded in hardware, you're not going to see it here. And it doesn't support interface-specific capture. Logging capabilities, persistent logging. So on the 7K, I don't know how many of you had the experience with the Catalyst 6K. So when you reload, what happens with the syslog? It's gone, right? 7K, when you reload, syslog, it's gone as well. However, we do have it also logged on this something called a log flash. So if you see a log flash there on your 7K, don't pull it out. Okay, make sure it's actually functional, because I've had a customer where he wants to know a root cause analysis of the switch crash. He has a log flash. I was all happy. When I did DIR, it's not formatted, so it's not being used. So make sure that it is functioning. Okay? It could be providing some really valuable information for us to troubleshoot.
How do you verify them?
I think you can just do DIR log flash and see if you see any of the contents there. Otherwise, it should show either it's not available. The description, the message is pretty clear. I think it's pretty. No, yeah, no. Constant logging. So on the Nexus platforms, we have this thing called constant logging. So each of the feature or protocol process that's running on the Nexus box would have this thing called the event history. So it's almost like a debugging that's being turned on all the time. The trade-off for that is the buffer is limited, so it can get overwritten. So if you have any issue and you want us to look into later on, capture the logs right away, or capture the show text right away, because it does get overwritten. If you wait, the problem might go away, it gets overwritten. And we also have a counting log, which is to make sure that nobody does anything unknown. So if you want to blame someone, look at the counting log, see who logged in, who issued what command, and who did the damage. So here are some of the commands, just for your reference. I'm not going to go through them individually. Yes? For the event history, unfortunately, no, I don't believe so. Yeah, it's only going to be syslog. So this is also one thing I personally like a lot on the Nexus platforms, because I did support the Catalyst platforms as well. The COI is very much, this time it went through fast. So it has feature-specific show commands. Like you can, anybody has gone through like 100-page long show run on your Nexus platform? Yeah, you don't have to do that. You can do, if you want to look at how the OSPF is configured, do a show run OSPF. If you want to look at how EIGRP is configured, show run EIGRP, right? So that, all this is going to save you a lot of time. And you don't have to do the do show, right, if you're not at a global mode on the Nexus platforms. And of course, the pipe is always there, and it's actually more powerful than other platforms, the Catalyst platforms. So you play with that. And the show commands are pretty well structured. If you have dealt with tech, you probably have seen that we run the commands like show system internal, show hardware internal, and the command is like this long, right? It's actually not that complex. So anything starting with the show system internal is usually the internal process running on the Nexus platforms. So like, for example, it's PM. It looks kind of cryptic. It's actually just Ethernet port manager. So anything related to that port physical interface that's handled by its PM. So if the port has flapped, it went down for unknown reason, that's probably something that you will see tech looking into. So you can certainly check on that as well. Show hardware internal if anything that's hardware related. So if you want to look at error logs, job counters, that's probably where you need to look. Show feature internal if it's a well-known feature, like ARP, OSPF, that's where you will find the commands. Okay, and some of other useful commands. Yes? I don't think any of these, but that's a very good question. So the question is, some of the commands need to be run from the VDC, admin VDC, right? Yeah, so these don't. In fact, if you have VDCs deployed and if you want to run commands, if you have one VDC that are experiencing problem, you actually want to run them within the VDC. Because if you run from admin VDC, you're going to miss a lot of information. But it's always a good idea to capture the output from the admin VDC as well as the VDC that is having the issue. But for example, some of the commands, yes, you do need to run from admin VDC, like the EDA analyzer. So if you look at the config guide, that's one thing, yeah. You can only run that from admin VDC. And if you want to check the COP, the control plane placing configuration, things like that, it's admin VDC. So granular show tag support. If you are coming from the iOS world, you probably would do a show tag, and you probably would be waiting there for half hour if you're lucky. So show tag on Nexus platforms are pretty big in general, especially 7K. And we have show tag detail. How many of you think, which one's bigger, show tag or show tag detail? Show tag is bigger, and show tag detail is often what we need. So capture show tag detail. Okay, capture show tag detail. It contains a lot of the feature show tags. It contains probably like over 10 of show tag feature. Basically, show tag ARP, show tag spanning tree. It's all part of it. So if you know, yes. Correct. So the question is, what do we do with the show tags? Do we just toss it, leave it in the back burner, or do we actually do something about it? Very good question. We actually have, in tech, we actually have this really big effort overall across the globe. We do the show tag parser, like an automated process, looking for diagnostic signatures, and we look into like proactively looking for issues that a customer might be hitting, but they're not aware of at the point. And of course, we also look for a signature or outputs that we can use to identify a particular problem.
Are you going through it line by line?
We don't. So I'm just being honest with you. I'm not going to go through a 1 gig show tag file line by line. No, I still want my life. So we look at the outputs that are relevant to the problem. If we have worked with you on the issue directly, we probably have a good idea. So show tag, again, do show tag detail. On Nexus platforms, try show tag detail. It's smaller. It has more relevant information to us to troubleshoot. And do show tag feature. So we look for show tag feature most of the time, because the problem is probably not happening for all the features. Like if you have a spanning tree instability, something's going on. We probably will start with the show tag spanning tree, right? If the soup has switched over, we might be looking at show tag HA, high availability, looking for sysmanager related information. And the other thing we use these show tags is when we speak, we escalate into the BU. Because some of the information, they are alien to us as well. We're in tech, right? But developers will know. So a lot of time we send them the show tag details, and they will be able to find more information. Yeah. So need to knows.
You just mentioned like show tag, tag have a positive, right?
Yes.
Is that all open to public?
Not yet, but it is on the roadmap. I will let you know when it becomes available. But no, it's only available for some of the platforms we have. But it's an initiative that we are using. In the past, we pretty much do the manual. We look for the commands that are relevant to the issue, and if we need to escalate them, we send the BU, the whole show files. Yes. So yeah, again, just to recap, capture show tag feature. If you know which feature might be causing the problem, capture show tag detail as soon as you can. Okay. So and before reloading the switch. Once it gets reloaded, we lose all the event history information. This actually was there with the iOS platforms as well. Rahul has one example in his case study where it's going to be used. So I'm just going to go through this. ELAM. I don't expect you guys to use this just because the output of ELAM is very cryptic. So usually you need to know the architectural level of knowledge on the platform, very platform specific. Some of the tech engineers don't know how to use it either. So, but you will see it gets used very often when you interact with tech. So just one thing I want to mention is it covers layer 2 to 4 data plane forwarding issues. So anything that's forwarded in the hardware, we can actually look into to see how it's being programmed, to see what's the forwarding decision being made, and sometimes why it's being made. It needs to be a consistent problem. If the problem is intermittent, we are not going to be able to use this. Because with this ELAM, we set a filter and we capture the first packet that hits the filter. Okay, so if you want to capture the packet that's being dropped, it's not going to do it. And it's not a replacement for either analyzer or span. So here's just a quick summary. The ones that are being highlighted are the ones that I went through, but we do have other tools that you can certainly use. If they're hardware, then you can do OBF onboard failure loggings, Go test, and debugs, programmability, and all that. I think in the PDF, it actually includes some of the hidden slides as well, covering all the other tools. Okay, so with that said, Rahul.
Check. You guys can hear me? All right. Thanks, Jane. So, okay, before I get started, a very quick introduction of myself. My name is Rahul Parmeshwaran. I've been with Cisco for 6 years as a tech engineer. I started off as a LAN switching engineer, just working on Catalyst switches. And over the last 3 years, I've been focusing on Nexus switches. Now, I have my CCIE in routing and switching first, and I just got my data center quite recently. Well, with that said, let's get started. So the goal of what I'll be doing now is to incorporate whatever you guys learned, when Jane presented her part of the session, and to tackle real tech cases. So I want you guys to help me troubleshoot, and let's see what we can do together. Right? The first issue, right? This was a problem that I got not too long ago, maybe last month, where I had a customer migrate from 6500 to Nexus 9000. So anyone doing that, migrating from 6500s? A lot of people, because we're seeing that a lot of people are going from 6500s to a 9000. And they were fairly new to Nexus platform, so they open a case saying that, hey, we moved all of our services from a 6500 to a pair of Nexus 9000s. And as soon as we did that, all hell broke loose. Applications that was working fine for the last 7 years started failing. And phones are all dead. No one's able to make a call. And few servers are not reachable at all. Right? It almost sounds like, and this is what the problem description, that came in as a tech case, and it was a severity 1 network down case. And I still remember the customer telling me, hey, Cisco, you've got 30 minutes, capture the information that you need, we're going to revert back to the 6500. And I was like, okay, hold on. I would probably need 40 minutes and we'll fix your issue. But yeah, just give me that much time, And they were also running out of time. They had the window, coming to the end of the window, but this is what, was presented. So at a very high level, this is how the network looked like. They were moving from the 6500 to the pair of Nexus switches, and all of their access layer switches were Catalyst 4500s, and they had them connected in VPC to the Nexus pair. And they moved all of the SVIs from the 6500 to the Nexus pair, and making them the default gateway for all of their devices. And this is how they moved their network. Now, what is it that you would do? First thing, the customer has described multiple problems. And honestly, it's impossible to troubleshoot all the problems at the same time. So I always ask the customer, hey, you've got multiple problems, that's fine. Let's troubleshoot one problem at a time, right? And how do you decide what problem you want to troubleshoot first? Sorry? Exactly, the problem that hurts most, right? The problem that's really critical. Let's focus on that. And many a times, fixing one issue ends up fixing all three issues or multiple issues, because all of the issues were a result of the same problem. But in any case, right, I've broken down it to three different issues: slowness across data centers, phones not working, and servers completely not reachable. Okay, again, the same slide. Oh, you have to ask the customer, I don't know. So the question is, why isn't the customer connecting it to the 6500, you mean? So the question is why they didn't have a VPC from the 6500 to the Nexus. That's because they were moving all of the services eventually to the Nexus and getting rid of it. Yeah. You could do that, but they had already done this, right? And that's when they call TAC. Well, yeah, there is a way you could do it. Oh, you do it? Yeah, exactly. A lot of people do it. Yeah, cool. So let me go back here. Anyone want to volunteer? And what is it that you would do if you are a TAC engineer talking to this customer, or if it was your own network? Show VPC, okay. He says he wants a source IP, destination IP, and an application. That's a very good point, right? So that is what I did. I said, hey guys, let's pick one application that was completely down or very slow. And they gave something which, not exactly an FTP, but something similar to what FTP does. And the first question is, are you guys able to even log into the server and start downloading the file, or what exactly it is? And the customer was like, yeah, we are able to log in, but the files which took 2 or 3 minutes is now taking 30 minutes, the exact same file. It's the exact same server, the exact same user. The only thing that's changed is from the 6500 to the Catalyst. And we see that it takes 30 minutes instead of 3 or 5 minutes. And I was like, okay, yeah, that is a problem, sure. And yeah, they were blaming the Nexus. They were like, isn't this supposed to be a very fast platform? But anyways. Next logical question, right? Who? Are all users affected? Or only a few users are affected? And why is it important to ask that question? Because our goal is to simplify and narrow down where the problem is happening, right? He says, the customer was like, no, all users are affected, yeah, but all my users are on VLAN 50. Yeah, okay, that's fair enough. It could be a problem with the VLAN or all the users, we don't know, but that's a good data point. All users are affected, all users are on VLAN 50. Next logical steps, what do you think we can do? Anything that you can try? So what if I move a user to a different VLAN? What happens? Because almost all of your users are on VLAN 50. Very quickly, let's narrow down if the issue is with VLAN 50 or does it affect other VLANs. And we quickly did that, and he says, yeah, we moved the user to a different VLAN, and it works fine. The file is being downloaded. So what have we done so far? We've taken the problem as all users are affected, and we're asking the right questions, who, when, where, and by testing this particular methodology, we've somehow narrowed down that the users in VLAN 50 are specifically affected. They cannot, their application access is very slow. Okay, so Next logical step, okay, I actually put this. So this is the next, are all users connected to the same access switch, right? Maybe that's why it's happening and you move them to a different switch, or very, very unlikely the case. They said, no, our users are everywhere. We have multiple floors and each floor have users and pretty much all of them are affected. So it's not a particular access switch. It's not, so what does that mean? What is the common point of failure when it's happening across the network? Sorry? The VLAN, okay, the VLAN, yes, and also maybe the core of your network, right? That's the common point where almost every user has to first hit, after hitting the access switch to go to the FTP server, right? So we've somehow narrowed down, okay, the issue is specific to VLAN 50, and it's specific to, it's somewhere in the nexus, because if it was an issue with the access switch, it should have affected only that portion of the network. And could it be an issue with the FTP server? Very unlikely, because as soon as you move a user to a different VLAN, it works fine. So, let's rule that out. Let's keep that in mind, but I don't think we should focus on that. Okay, now that we've narrowed down the scope of the issue to these two nexus switches, and specifically to VLAN 50, what next? Right. Interface drops. You think we should look for interface drops? I would say it's very easy to show interface counters errors. I would say, logically, yeah, it does make sense, but when you think about it, it cannot be interface drops when it's affecting just one VLAN. And if you just move the same, the position of the FTP server is not changing, the position of the user is not changing, but if you just move the user to VLAN 50, the problem is seen, and if you move it to a different VLAN, it's not. So most likely not an interface drop issue. Then what else could affect a VLAN globally? Spanning tree, awesome. Do you like spanning tree? Yeah, I don't like it either, but it's still out there. So could spanning tree be a problem, right? So you could quickly check show spanning tree VLAN 50 detail from the core. What is it that you look for? You look for too many topology changes, because with every TCN, a topology change that you get, two things happen, right? The topology change is propagated to all switches in that VLAN, and as soon as the switch receives a TCN, it flushes out its MAC address table, and while it does that, there could be periods of excessive flooding in the network because the MACs are not there. Now, was it spanning tree? In that particular customer's case, no. Spanning tree looked clean. And what next? We've looked at spanning tree. We've looked at, the core switches, no interface drops. What could be slowing things down? Sorry? Layer 2 and go up? Okay, that's a good point. Anyone else has a suggestion? HSRP, maybe on VLAN 50, where you always see an HSRP issue. I'm just, that could be a case, but why should HSRP slow things down? If there's a problem with HSRP, I would see complete network connectivity loss instead of slowing things down. So always, I've learned it through experience because we deal with a lot of customers. When things are going slow with any switch, it may be getting, QoS is a good point, but the forwarding part, it may be getting software switched. You pay for the Nexus 9000 or 7000 not because of its CPU. You pay because of the ASICs. There is one question. Yes? So the question or the comment was, what if you ping from the user or the default or the access switches to the core or the default gateway and trace the path? That's a good point. I would typically use that if there is, say, connectivity loss through pings, or this complete connectivity or black holing of traffic. You could use that to narrow down where exactly the packets are getting lost. But here, it almost feels like the user is able to connect to the end station, so there is IP connectivity, but it's just very slow, right? So that's a good point. You could use that, in a different scenario. So I was telling you, right? You guys pay for the ASICs and not for the, for it to be CPU switched, because the ASICs can switch traffic at line rate, whereas the CPU would do it like 1,000,000 times slower. So that's a data point again. If things are very slow, let's see if the packets are getting software switched for any reason. Now, how did we reach to this conclusion? We reached to this conclusion by asking the right question, narrowing down the problem to the pair of nexus, ruling out interface drops, ruling out spanning tree, and then finally, let's see if it's getting software switched. How would you do that? ETH Analyzer, like Jane was telling, right? ETH Analyzer is a tool on the nexus, on all nexus switches that gives you visibility to the traffic going to the CPU and from the CPU out. Now, I ran an ETH Analyzer capture, and I could clearly see this particular traffic was getting software switched. So we have narrowed down the issue. Like, this is the problem. This is the reason why, things are a million times slower, because traffic is getting software switched. Because you're seeing it in the ETH Analyzer. The question is, what tells you it's software switched? Because you're seeing traffic from a user to a FTP server, which should be completely hardware switched in the data plane on the CPU. Question? So that's a very good question. Would you see high CPU if things are getting software switched? The answer is, on the Nexus, no, because we have a policer called it's called the control plane policer, a COP, that pretty much polices a lot of this traffic. So if you check COP statistics, you would see drops, but we kind of mask the problem by rate limiting this traffic. And eventually, some of this traffic leaks to the CPU, right? And that is why you can still see it with the ETH Analyzer. It's what traffic that leaks through COP, the policer, and makes it to the CPU is what you see. So you would not really see high CPU. If it was a 6500, maybe. Yeah, high CPU on 6500, I remember those days. That's still one of my favorite switches, though. Yes, question? What causes software processing? I'll tell you that in my next slide. So let me, what questions, comments you have so far? Anybody has any doubts as to how we narrowed it down to software switching, or maybe there's something that you wouldn't have done? I just want to make sure what you would have done if you were put into such a situation. Just feel free to comment and stop. So the question is, does ETH Analyzer only show you software switched packets? The answer is yes. It's only packets going to the CPU. It could be traffic like this, which is getting software switched, or it could be OSPF traffic, spanning tree protocol packets, all your control plane packets that can also be seen. The beauty about ETH Analyzer is, if you see, I have put in a capture filter to TCP, right? So I'm only capturing TCP traffic, and ideally I shouldn't be seeing TCP traffic unless you're SSHing into the box, hit the CPU. Question? Oh, I'm sorry. You can go ahead. I'll come back to you. So, the question is, could we have used PACL? The answer is no. PACLs would come into handy to just confirm if the packets came in, right? So maybe by doing a PACL, you could confirm, yeah, all the TCP packets are coming in, but what is the switch doing with those packets? We don't know. So PACL would not have been relevant in this example. You have a question?
So with all the additional features coming into Nexus and all the stuff that's causing the packets to be software switched more often, how common has it become that you guys run into this as a cause when you do have a
Okay, the question for the rest of the audience is, how common has software switching become because of various issues, right? I think from experience, there could be some feature that's not programmed correctly in hardware causing packets to get software switched. The answer is it's not too common. I would say less than 1% or 0.5% of the issues that we see are caused by this. But when this happens, very difficult for someone with not using the right. Even tech engineers sometimes miss this, unfortunately, right? They go chasing in the wrong direction, and we spend hours and hours. And if you could have caught this, you could have fixed the issue. Once you find out why it's getting software switched, narrowing it down becomes a lot easy because there are very few reasons that this can happen. Oh, damn it. I should have waited for the animation, but traffic is getting software switched. So that's my story. All right. The question is, okay, traffic is getting software switched. Why is it getting software switched, right? Different reasons. Packet with IP options, this could result in packets getting software switched. In this case, it wasn't because it's relevant from the problem, right? If it was IP options, even the 6500 would have been switching the packets in software. Packets with length greater than the MTU, what happens? Fragmentation. Fragmentation is always done in software. So that's another clue, right? Are the packets, maybe you have not set the MTU correctly. In this case, MTU wasn't the issue, it was set correctly. This one, I don't expect people to know this, but this is one big issue, that IP redirects. You understand what IP redirects are? Quick raise of hands, or you know what? I'll tell you what IP redirects. So if say the packet comes in from a user on VLAN 50, hits the nexus, its default gateway, and the next hop towards that particular destination is a device which is also on VLAN 50, the nexus or any switch says, hey, wait a minute, why are you sending the packets to me? Why don't you send the packets directly to this guy who has a route to the end destination? So that's redirect. So whenever Nexus has to redirect packets, it does that through software. This is one big difference between 6500 and the Nexus. What 6500 does is it creates a copy of the packet and punts the copy to the CPU, whereas the actual packet is hardware switched. So you may not see performance issues, unless you will see high CPU though. But with the Nexus, the original packet is getting software switched to generate a redirect, but once it gets software switched, it makes it across, but it's getting heavily polished with the control plane polisher. Question? Or what about like WCCP? Ideally, WCCP should be completely switched in hardware. We've seen issues when it was getting software switched. It's either a configuration issue or if it's an old code, it could be a bug. But yeah, to answer your question, it should be hardware switched. Question? The question is IP redirects enabled or disabled? By default, IP redirects is enabled. When you enable, I know for sure when you enable VPC, if you're doing VPC and you enable pure gateway, we automatically put in no IP redirects, but I don't think we do that with HSRP. I'll have to check. I don't remember. Question? The question is, IP redirect is enabled by default on the Nexus. That's why this happened. So what would you do to fix it? Just go say no IP redirects. So honestly, I don't know any device that has responded to an IP redirect. The server's like, I don't care. I'm not going to redirect packets. I'm going to send it to you. You do your job. That's what happens. The question is on the SVI or globally. We can do it both ways, but here I did it on the SVI.
So if your SVIs are on, like, say, Catalyst pair, and you had Nexus below that as your distribution block, to no IP redirects on your SVIs, then you would run that same global command on Nexus.
So the question is, do we have to do both on the SVI and the global? Not necessarily. You can do it on a per SVI basis. And yeah. And I always tell the customer, I've never even tried doing it globally. Just put no IP redirects on all SVIs. It's of no use. Maybe I should file an enhancement to disable that feature. Yep.
Can we do the command by default, say by format with no redirect? Set on
So the question is, can we do it by default? When you say default, do you mean globally?
Yeah, for instance, I can say, okay, by default, my all encrypted word set that.
You can disable IP redirects globally. That would be applicable to all your interfaces. But while the switch boots up, you'll have to still manually go and configure it. No.
Okay, sorry guys, I think we have to hold off on the questions. We have 30 minutes left, and
Yeah.
Rahul has some more really
Very interesting.
Yeah.
We can come back to questions,
Yep.
Hardware misprogramming, like the gentleman was saying, right? You may have some ACLs or WCCP misprogrammed. It's going to the CPU. Call TAC. I don't expect, people without platform-dependent knowledge to troubleshoot, beyond those first three issues. All right, second issue, right, is phones not working. So we've solved the first issue. We were able to solve it in under 20 minutes. So we still had 20 minutes before they had to cut over. Again, back to the basics. Why are all, what is your question? Is it what all the phones in your network, they're completely, not working? And the question is no. Because again, phones in VLAN 10, specifically. So you've narrowed down the issue to, phones in VLAN 10 not working. So, for people who worked with IP phones, the first thing that an IP phone does, it gets power either through power over Ethernet or, externally, and then it has to get an IP. And almost every deployment that I've seen, it uses DHCP to get an IP. And the phone, the engineer says, hey, it's not able to get an IP. And all this was working, remember, with the 6500. So next logical step is to, within the DHCP process, the first packet is that a client sends a discover, which is a broadcast, and that discover has to make it to your DHCP server. So do a quick TCP dump or Wireshark on the DHCP server to see if the discovers are making it.
Before you get that step, do you know if these servers are on the same segment or story?
I'll come back to that. Man, you stole my thunder. No, I'm just kidding. So, are all phones connected to the same switch? The answer is no, it's across. So, again, it seems like it's affecting phones across the network, so start troubleshooting from the core, because the core is the gateway, and in order to reach the DHCP server, you've got to go through the gateway, which is the Nexus pair. Yeah. This is the typical answer I get, hey, what is different about this VLAN? Yeah, no difference, which more or less, yeah, I mean, there usually is some difference or the other, but most of the time they say no difference. Okay. Tell me something about your DHCP server, where are they located, what's the IP, and so on. And the customer says, yeah, we have 3 DHCP servers, but only one is active at this point, and the server is on VLAN 10. So what did we find? We found by just asking questions that the DHCP server and the phones are on the same VLAN, and it's that for some reason it's affecting. Now, you would start scratching your head, because it's common sense. All of us have learned that a broadcast packet definitely makes it to everyone within that segment. And if you see issues, it could be, a broadcast from one segment has to be relayed and sent to another segment. You would expect issues there, but here it's the other way around. Same VLAN not working, inter-VLAN is working fine. And what do you do next? Is the packet even coming to the Nexus switch? I know it's not making it to the DHCP server, but is the Nexus getting these discover packets? You can do that using Ethernalizer, because it's a broadcast and you have an SVI, it should be punted. So what we found, I kind of knew the answer, but I'm just telling you, because we've seen issues with exact same symptoms in the past, so we know what's happening. But if you noticed, the DHCP discover packet is getting punted to the CPU, and the Nexus is relaying it, but it's relaying it, to 2 IPs there. And those 2 servers were actually the ones that were not really in production. And when I asked the customer, hey, why haven't you, why, and the customer's like, why isn't it sending it to, the server, which is supposed to be our DHCP server? Then I look at the config, the customer hasn't mentioned, the same VLAN server within as a relay, right? So on the Nexus, it's a little different. All DHCP packets are punted to the CPU. It's not flooded, right? If you use relay, and the customer assumed that since it's a broadcast, it will make it to the server in the same VLAN, so I don't have to have a specific relay statement for that same VLAN server, which turned out to be, wrong. So again, the idea is I don't expect people, even tech engineers without Nexus experience to be able to root cause this issue, but at least narrow down that, hey, the packets are coming to the Nexus, but it's not sending it to the server, so what could be wrong? And if you come to tech because of the knowledge that we have, we would quickly be able to tell you, you got to include the same VLAN DHCP server as well. So it's like the mantra is to just, narrow down the issue, and then fixing it becomes very easy once you narrow it down. Last issue, I'm kind of rushing, so let me know if if I have to slow down. But this was a third issue. So we've solved 2 under 30 minutes, so we had 10 minutes to solve the third issue. And it was a vague statement. It says, our monitoring station has no reachability to a few servers. And all of this was working fine. And what is it that you ask? first question is, go to its default gateway and ping the servers. Are you able to ping the server from the Nexus, right? The monitoring station may be in a different VLAN. The servers are in the same VLAN as, the default gateway is the Nexus, so are you able to ping? And the customer is like, yes, we are. So the next logical step would be, ping the same server, but source a different VLAN IP. What are you achieving by doing this test? You're trying to figure out if inter-VLAN routing for those servers are working. So you're forcefully making the server respond back to a out-of-subnet IP, by sourcing the pings from a different VLAN. And that was failing. And I was like, you know what? It's common sense. If a server can reach its own segment and cannot reach other segments, something is wrong with its default gateway config. That's what I told the customer. And the server team guy he was not happy, and he's like, oh, this has been running for 7 years with Catalyst 6500. What are you saying? And I was like, I mean, that's common sense, right? I mean, I don't know. He's like, no, I don't buy that. It's been running fine. We haven't touched those servers. Okay, then let's use our tools again and see what is happening. So when we ping from the switch, you would expect a response. So let's see if the switch is getting a response or not. Ethanalyzer, because you're pinging from the switch, it's traffic sent from the CPU and back to the CPU. And I did an ethanalyzer for that server, and this is what I found. It was sending an ARP request for the destination it was trying to reach instead of its default gateway. So when would a server do this? Subnet mask issues, or it doesn't have a default gateway configured. Right? In that case, they did not have default gateway configured on the server, and proxy ARP is enabled by default on the 6500. So 6500 was proxy ARP replying for all of this ARP request. It's disabled on the Nexus. And they had this running for like 7 years. Right? I mean, I don't blame the customer. Everything's working. Why bother? But the idea is to, we enabled proxy ARP under the SVI, and it worked. Right? It's just and they eventually fixed the default gateways on the servers. So moral of the story, right? We were able to solve all of this in 40 minutes, and the customer had spent close to 3 hours trying to troubleshoot by themselves, and they reloaded both the Nexus switches, thinking that it's a core issue. And once all of that didn't work, they called TAC. Right? So they spent at least 3 or 4 hours in the window trying to troubleshoot, and then they engaged TAC in the last 1 hour saying, collect information that you need. We need a root cause analysis. So how did we solve these issues? Again, going back to what Jane described to us, you see we've used the same methodology. Take them as one issue at a time, asking the right question. See, our goal should be to narrow down the scope of the issue. Take it from network-wide to a specific server or to a specific access switch. That should be our troubleshooting goal. Ask relevant questions so you can pinpoint where exactly the issue is happening. All right, once you do that, it makes it a lot easier. You can use tools, logical reasoning to finally root cause the issue. All right, with this, I conclude my first case study. Do you guys think, okay, I just want to quickly ask you, was it, something different that, TAC engineer did versus what you would do when you were put into the, this situation? What is different? It was still, we asked the same questions. We didn't use fancy tools. I mean, Ethanalyzer is a useful tool, but it was just, you could have done that without an Ethanalyzer, right? All I want to show you guys is by asking the right questions, you will be able to, narrow down the scope of the issue. And that's the moral of the story. So, case study 2. This is a very interesting case. At 1 a.m. every day, there's a network outage. Servers lose access to the network. This is it. This was what the problem came to us. And I was like, okay, cool. That's an interesting problem. The good thing is you know what time it's happening. Sometimes, it's very intermittent. We have no clue. We lose access to the servers, and more often than not, it's a pattern. That is what we observe. But in this case, this was a problem description. Now, very, very different from our first issue. But what I want you guys to understand is I'm going to tackle this issue using the same methodology as what I did for the first issue. Just to show you guys, problems may be different, but the methodology is going to be the same. Sure. So the question is, as stack engineers, what do we prefer? Do we want a concise problem statement, with the network engineers in your own company? It could be you guys or someone else troubleshooting it first, or you just want us to just start taking the phone and saying, oh, this is not working, that is not working, and so on. The answer is the first part, right? As much as you guys can, because you know your network better than us, try to narrow it down, But at the same time, don't spend a lot of time, because, time is money, right? The longer your network is down, the more money you lose. So if you feel, you're hitting a roadblock, you're not able to proceed, it's a good time to open a TAC case and get an engineer to look into it. And then you tell us what you guys did so that we don't have to repeat doing that, so. So, yeah, the question is, should the other customer had opened a preemptive case, like a proactive case with TAC? Yeah, I would say do it, but it's very difficult to get a TAC engineer to sit with you while you do the migration, because we cannot scale that way. But if they would have engaged TAC maybe in the first hour, we could have saved a lot of time. And there's no harm opening a proactive case, right? We see the customers opening proactive case, not everything goes smooth, just close the case. So you could do that. I would encourage you to do that. Just proactively open a case. Right. Going to this issue, what are the questions that you would ask? Anybody want to volunteer? Yeah, go ahead. Okay, do we know what's happening at 1 a.m. at your environment? Is there anybody there? Perfect. So that's what I asked. Are there any scheduled activities at 1 a.m. every night? Are you guys doing some backups? Any configuration copies? What happens? And the answer I got was, nothing that we're aware of. But we have a lot of monitoring going on, but nothing specifically at 1 a.m. that goes on throughout the day. So what do? I was like, okay. So scope, is the entire network affected or just a portion of it? Right? I want to narrow down the scope. That is my goal. And the question is, again, is everything affected? And the answer is yes, everything is affected. That's not helping, but anyways. What is done to restore network connectivity? Nothing. It's just magic. Someone does something at 1 a.m. It gets resolved by itself. So I think the data center is haunted. But yeah, how long does it last? 2 to 3 minutes. So this was the problem description, and we had to solve it. Right? Now, what is it that we would do? Sorry? Yeah. So where do we start, right? It's a vague statement, and the customer claims that everything is affected. I would start from the core, right? Question? Yeah. So the question is, where do you start? I would start at the common point of failure, which is most either the distribution layer or the core layer. Because every single traffic has to go through the core and then come from core down towards access. So check from the core, check what exactly, since the event happened earlier that night at 1 a.m., see, if we can find something, right? Any spanning tree changes, routing protocol convergence, logs, or any changes that the customer was making but not telling us. Show logging log for that particular time and show accounting log. Show logging log tells us what happened at that time from the switch's point of view, and show accounting log tells us if there were any changes or some commands executed. What I noticed is, VPC keep alive, it's a control packet that went down. BGP reconverged, spanning tree went haywire. And I'm thinking, oh yeah, definitely something is going on at that time. It's almost affecting every single protocol that they're running, spanning tree, BGP, VPC, everything is getting affected. And from the show accounting log, I just saw someone doing show access list. I'm like, oh, that's not, it's just a show command. So I still did not completely ignore it. I was like, okay, we still don't have conclusive evidence if that's the issue or not, but something to keep in mind. So when all your control plane protocols are affected, what do you think could have happened? CPU, perfect. If the CPU goes high, you would pretty much see all of your control plane traffic affected. Because if the CPU, for some reason, is not functioning the way it's supposed to, you typically see all your control plane protocols flap. So I check show process CPU history, and you see that? You see a spike all the way to 100%. And the customer is like, I have COP, CPU should not spike. I was like, yeah, COP protects you from traffic, right? But if something is happening to the process, something is within the NXOS, the Nexus operating system, and spiking, COP may not protect you. We don't know. So the customer is like, okay, what is happening then? What would you do? It happens at 1 a.m. every day. The customer was like, okay, do you expect me to log in at 1 a.m. tonight and keep checking show process CPU? And I was like, yes. And no, I was just kidding. I told him, no, you don't have to do that. Just sit back, relax. But yeah, just wait for it to happen again. Use a script, EEM. What the EEM script does, like what Jane was saying, you could trigger it to take a certain action based on an event. So since we have narrowed down that from a symptom, we've narrowed down to a problem, saying that the CPU went high. So we've narrowed down that it's high CPU that's causing all of these issues in the network. So we're going to find out what process is spiking. So the next day, the script ran, and we found out it was ACL manager. So ACL manager is the access list manager that went high. Now I just remembered, hey, they were doing show access list that actually caused the access list manager to spike, right? And eventually we found out it was a bug in the NXOS that they were running. It was a very old code that every time they do show access list, they had about 40,000 access list entries on the switch, and they're trying to poll the entire ACL. And because of a bug, the CPU did not schedule the process correctly. It let this process affect the other process. So spanning tree took a hit, VPC took a hit, and BGP took a hit while this was happening. So we were able to quickly narrow down the issue and fix it with a code upgrade. They stopped doing that, show access list. But what is the moral of the story? So before that question. Don't have any.
Do you guys have a session here that does this?
Yes, there is a session. Okay, is there a session for tools? There is a session that covers all the troubleshooting tools on Catalyst and Nexus platforms. I can tell you the session number after the meet. Yes, please. So this customer had they were actually a provider for other customers, so they had to be compliant with rules. So they were polling the access list just to ensure that they had all the statements that was in place. So they had a software that was polling the entire access list, parsing it, and ensuring that it's all correctly configured. Yep, question.
So that script right there, it's not scheduled all the time. That was actually looking at the hardware CPU voice right?
Yeah, so the script says trigger when the entry up, this is the SNMP OID for the CPU, if it exceeds 90, and keep running the script until it falls below 50%. Yeah. It was appending it. This means append. If you had only one greater than sign, it overwrite. So, guys, what is it that we did? We took a very vague problem description, and by asking when, what, why, we were able to narrow down the scope of this issue and then use troubleshooting tool to fix the problem. So my methodology didn't really change between my first issue and the second issue. I still asked relevant questions, and my intent or my objective was to narrow down the scope of the problem. This is one of my favorite. This is a very interesting case. It says the network was severely degraded for several hours, and it recovered. We need a root cause analysis. This was a big enterprise customer that resulted in, the number is over $10 million of revenue loss. And a very famous customer. I cannot disclose their name, but yeah, this was the case. And it came to us after the event happened. Tell us what happened, Cisco, that our entire network was down. And again, my methodology is not going to be different. It's a very different problem. The first problem was something happening currently. The second problem was very trivial. The third problem is a root cause analysis. Different signature. Again, my methodology remains the same. I keep telling you this because that's the truth. What specific applications were affected? And I get the answer, like everything was down. Okay. And what were the symptoms like, where you're not able to connect to the applications at all, or once you connect, was it slow? And the customer was like, we're seeing both. Sometimes the users are able to connect to it, but a bunch of users, even though they connect to it, it's very slow to run those applications. Okay. My favorite question, what changes were made? Something broke the network, something recovered it. What changes were made? They said no changes, but I read it as no known changes. Right? Never, because there has to be something, that went wrong. And what was done to fix it? Again, nothing known was what I put in, but the answer that I got was nothing. So I don't blame the customer, right? Because it's a very big enterprise with like 100, 200 network and server engineers. So, the guys whom I was working with, they were network engineers, and they didn't know what happened. They said nothing really changed. Timelines. It's very important for us to find out when did this start, when did this stop. Why? Because you're only going to focus on the events that took place within that time range. It says that the issue started at around 1 p.m. and the network was stable at 11:30 p.m. They had such a significant outage. And I don't know why didn't they involve TAC earlier, but yeah. So they had, how many hours is that? 10 hours? 10 hours of downtime. Okay, again, it's a root cause analysis. What do you do? Where do you start? Where do you start? Everything was affected. Start from the core. Start from the core. It's a network-wide event. So what affects the entire network? A spanning tree, right? A routing loop, firewalls, okay? Broadcast storm. What if you have flooding in your network that could pretty much eat up all the bandwidth, affecting your protocols? So all of these. So how do I know this? It's through experience and through knowledge, right? So you need to have some experience and knowledge to know what could globally affect your network. So I start from the core, and I check for interface drops. I check for spanning tree. I check for all of the logs to see if, we can find something. And they were running Nexus 7000, so you also inspect control plane policing to see for any reason did the policer kick in. Okay, and I asked the customer to check their SNMP tool to see, if they saw any high CPU alerts, any high memory utilization, any drops, and so on. They had tools, but they didn't poll the information. Rather, they were polling the information, but they were doing nothing with it. Right? And honestly, this was a very big enterprise customer who had all the information but did nothing with the tools. So we had to go back and check. So I checked through spanning tree. Spanning tree looked very stable. So, I don't see too many TCNs. So if spanning tree is stable, okay, let's move on, right? We've kind of ruled out spanning tree being, even though spanning tree is a bad protocol, it's not always the culprit. So interface drops. Show interface counters errors. And this is what I observed. And do you guys see a pattern here? Now, this is something you got to catch, right? You see some pattern drop counters on all ports. So what traffic, if I have to think to myself, would be sent out of all your ports? It has to be a broadcast traffic. Immediately when I see a pattern like this, I think broadcast. Okay, that is why you see similar output drops on all of these ports, because it's a broadcast, and all of these ports on the switch were trunk ports, carrying VLANs, so it was pretty much going out of all ports, and all of them were equally overutilized, so you see similar drops. I looked at control plane policing, and this is what I found. ARP took a very big hit, and there were so many violations. What does violations means is that the number of ARP packets that came into the switch exceeded the 680 kbps, so we started dropping it. So the rate limiters kicked in. So what have we found so far? We found out that there was a broadcast storm, right? Oh yeah, and this was the SNMP graph. This was an awesome tool that the customer had, but they didn't even know they had it. It clearly shows at 1 o'clock there was a spike of non-unicast traffic, which was broadcast and multicast. There was a spike all the way to 30,000 packets per second. I think that was the scale. And you see this? It almost, what does all of this tell you? What if someone had paid attention to this at 1:30? you could clearly see that there was a broadcast storm happening. So this customer, to be fair on them, it was a lot of pressure. They didn't know what was happening, so they went all over the place. Applications, pointing fingers at the server pointing fingers at the network, and so on. And so what have we learned so far? We've learned that broadcast storm on the network, and storm is that of an ARP packet, right? Because the ARP policer kicked in. ARP storm has caused congestion, right? Pretty much when control plane policer kicks in, it doesn't distinguish between a valid ARP request and a broadcast storm ARP request. It just rate limits them. So a server could be ARPing for its default gateway, and that could have been rate limited, resulting in reachability loss to that server. Okay, we found, okay, this is your root cause. You had a broadcast storm, and the next question is, okay, what caused it? What do we do next? So the broadcast packet comes in, right, to the switch through some port. It has to come in to go out. So which port did it come in? So show interface counters. It clearly tells you in broadcast, and we saw that all of these packets were coming in from a specific port. So we started off from the core. We started tracing the in broadcast, whichever had very high counters, and eventually we were able to narrow down, these counters coming from, a bunch of servers. And what was found later on was that new applications were deployed on those servers, and the server team reverted the changes at 11, but the server team did not speak to the network team.
So it wasn't the network.
It wasn't the network. Yeah. So the mean time for innocence was 10 hours. You guys know what the mean time for innocence is? It's the average time it takes to prove that the network is not the issue. So okay, now lessons learned, right? What is it that we could have done to prevent it? Maybe had storm control. People just ignore all of these things because for 5 years things would be working fine, but that one day, a bad day, something like this can happen. And talk to each other, right? Every single change in a network has to be documented and exchanged, and you would end up solving issues. Unfortunately, I'll have to skip this section. We're running out of time, but I would encourage you guys to go through the slides because we have a hard stop at 3. So I appreciate it, guys. I just want to quickly conclude. Let me just go to that. Yeah, I just want to just talk about the do's and don'ts, right? Before doing that, okay, I just want to quickly take a poll. All of these issues, did we use any tricks to troubleshoot them that is not available to someone out there? The answer is no. Just want to show you guys, it's so important to ask the right question to narrow down the scope of the problem and then use your logical reasoning and tools. So the do's, understand how things work in your network, and I always tell people if you cannot predict how traffic flows from one application to another application, you haven't designed the network the right way. You should be able to predict how it flows, because if it's not working, you can go and check what exactly is happening or what path it's taking. Document every changes that you make. It could be on the server side, it could be on the application side or the network side. Document them, and when you're troubleshooting an issue, bring all parties to the table, right? It's important. I've so many times spoken to customers saying that, hey, I don't see this application working correctly. It's sending packets that it shouldn't be sending, and it takes hours to get an application engineer to join the call. So it's important that all of us work together, be it the server side or the application side. Stay calm. Well, it's very difficult to stay calm, especially when your network is down. I've had hospitals go down, 911 not working. I've been there in such scenarios, and it's important that you stay calm. You don't have a choice, honestly, because the more nervous you get, it's just going to make things a lot difficult to troubleshoot. Have a good diagram of your network so you can share with TAC or anyone who's looking into your network diagram can understand how things are connected. And pay importance to what your tools are telling you. You have so much SNMP monitoring. You've invested your time and money in monitoring. You should also take a look at what information the monitoring tools are providing you. And if you see something you don't understand, call TAC and get it clarified, or search for it. Don't ignore it. The don'ts, don't jump to conclusion like that first customer did. We rebooted both the cores because it had to be a core. but they shouldn't go. And, with reloading switches, something else could have happened that could have resolved the issue, but we've lost so much information that, could have been helpful to root cause this issue. And don't try to troubleshoot multiple issues at the same time. It doesn't work. I can tell you from, 15 years of troubleshooting experience, take one issue at a time. And if you're trying to revert changes that you make, make changes one at a time, or revert changes one at a time, so you know what specific change caused it to break and what we could have done, or what we would recommend you do such that it doesn't break. So it might all sound common sense, but honestly, we see, working with a lot of customers, that common mistakes people tend to make. Yeah, and with that, coming back to this, that is the root. The answer is there is no secret ingredient. It may sound like common sense, but just our goal is, Jane and I, was to teach you guys how do you troubleshoot the issue. Be it any issue, our methodology remains the same. By asking the right question, you narrow down the scope of the problem, and then once you narrow down, use tools to resolve it. Yeah, with this, we conclude. Sorry, we had to hurry up in the end. We should have done a better job at time management. But I really appreciate you guys attending this session, and I really hoped it helped you, or maybe in future, hopefully you guys don't have to troubleshoot networks, but if you do, remember the right methodology. Thanks again. Please complete your session.